Okay, so chapter 8. Chapter 8 is, we're going to do a new issue. It's about the mathematics of scheduling, as it says. Basically, it's like how managers schedule employees to do jobs. And we want to use math to help us do it efficiently. So both these chapters, 6 and 8, are management science, if you will. If you're going to get an MBA or things like that, these are using math to manage things well. We just finished chapter 6, which how you manage visiting a lot of locations efficiently. Chapter 8 is how you manage getting a bunch of jobs done efficiently. So what we need to realize is if you're a manager, like say you're a construction manager, what does a construction manager do? He or she comes in and manages a bunch of subcontractors. Got to build a house. So a bunch of houses going in Fresno, aren't there? I always see houses coming in all over the place. So manager comes in and says, all right, the construction manager, I need to hire the roofer, the plumber, the person that's going to lay the foundation, the people going to put up the walls. All right, I'm going to call the roofer first. Come on over, roofer. Get going. Well, that's the problem, huh? The roofer can't be coming over to do his job until the walls are up, and you can't put the walls up till the foundation's laid. You can't do the foundation unless they put the plumbing in the ground first. There's an order to which you must do certain jobs, and so the manager must have different people come out and do different jobs in certain orders. Certain jobs lead to other jobs. That's real life when you have jobs or tasks. So we're going to try to use math to manage jobs in the most efficient way possible. So in order to do that, just like the last chapter, we first need a hammer. We need some tools to do that job. The tool we're going to use is called a digraph. Di stands for directed graph. We're going to have, basically it's fancy arrows. Fancy way to say arrows. We're going to have arrow diagram. We're going to have a bunch of arrows up there. Why? Why arrows? Because one job will lead to the other. Like the plumber, when he gets his work done, or the walls, the person gets the walls up, that'll lead to the roofer in real life, right? So when we get to the real life applications, we'll be looking at one job leading to the next job, and that'll be an arrow. And so to use math efficiently, we'll have a bunch of arrows on our diagram, and we'll position the arrows and do things with the arrows as a good tool to help us manage the employees wisely. So let's get used to the tools then before we start doing the jobs. Monday we'll do the jobs. So what are the tools? So this is pretty easy. It's called a digraph. Directed. Di stands for directed. Directed graph shown on the right. Part A says, give the vertex set and the arc set. So what is the vertex set? Well, there's the answer already for you. A, B, C, D, E. It just means what are the points? Vertex is a fancy word for points. A vertex is a point. So the vertex set is the set of all the points. Well, A, B, C, D, E. There you go. So they just want you to list those with commas. All I've done there is just listed A, B, C, D, E with commas. And then the next part says, give the arc set. An arc is an arrow. An arc's an arrow. So the arc set means list all the arrows. So like, what's this arrow first off? That's arrow AB. Because it goes from A to B. It's not BA, it's AB. Because it starts at A and goes to B, right? These are directed, so the order matters. AB would be different than BA. BA would be an arrow going from B back to A, right? That'd be a little different. So that's arrow AB. You can do these in any order. How about arrow CB? How about arrow CD? I'm just going to shade them in as I go. See, I'm just shading them on the diagram as I go. EB. AE. What's this one? DE. And AD. Oh, and one more. EC. There we go. I listed them in any order, doesn't matter. There we go. That's just all the arrows. That makes sense so far? Getting with the lingo, the language used in this chapter. Now it says in part B, stop me if you want to talk more about this. Part B, it says, okay, complete the following table. It's going to give me the vertexes, the vertices, they're called the points, and then the in degree. So that word right there, the in degree, that just means how many arrows are coming in. So at point A right here, how many arrows are pointing in to A? None. That's why it's a 0. At point B, right here, how many arrows are pointing in to B? Well, 3 of them, etc. Is that good so far? Again, this is just the tools we're going to use to answer real-life management questions. See how math works in the real world? Math looks at a problem in the real world and then designs some kind of tool to help efficiently deal with it, and then dives in. Oh, that bottom, it's kind of off the screen, I guess. Here, I'll go. So last thing is out degree. So vertex A has how many arrows going out? Well, 1, 2, 3. And you know, B has how many arrows going out? None, etc. We good there? I'll move along if you're okay. So here's number 2. So number 2 gives us another digraph, directed graph with arrows. And its first question is, how many arcs in the digraph? An arc is an arrow, right? How many arrows? We'll just count them. 1, 2, 3, 4, 5, 6, 7. And then it says the sum of the n degrees. Sum means adding up, right? So it wants you to go around and add up all like how many arrows pointing into A, for example? What's his n degree? 1 arrow pointing into A. How many arrows pointing into B? Over here to B. 2 pointing into B. How many arrows pointing into C? 1. How many pointing into D? 1. How many pointing into E? 2. Add those up. 1 and 2 is 3, and 1 is 4, 5, 6, 7. Of course. Don't count them like that. That's silly. How many arrows are there? 7 arrows. How many tips? Well, 7. So how many in pointings does there have to be? 7. Don't bother counting them. Right? See? They're just making that point. They're trying to get you to start thinking mathematically. Right? Every arrow's got an in and it's got an out. So how many out degrees? Well, 7. Because every arrow points away from something and every arrow points into something, right? So don't go around and count like I just did, right? It's going to be 7, right? So there's starting to, and this is what math does. It comes into an area, you start thinking, oh yeah, of course, the in and out is always going to match the number of arrows. And you start making good logical conclusions and speed up your thinking. That's how math serves real life. All right, in this world. Okay, so it's using the word incident to. That means points in to A. Incident, pointing in to A. So how many point in, or which vertices point into A? Only this one, right? From E to A. So only E is incident to A, points in to A. Only point E points into A, has an arrow headed into A. So in real life, on Monday when we have, we'd say, what jobs need to be done before the foundation is laid? Well, the plumbing has to be put under the ground before the foundation is laid. We'd say, what jobs need to be done beforehand? So which vertices are incident from A? So which ones come out of A? Well, A only points at B, right? And finally, which arcs are adjacent to BE? Which ones? Adjacent means next to. Which ones are next to the BE one here? Here's the BE one. Which ones are next to it? EAED. Oh, I guess adjacent means comes after. Okay. Adjacent means, I don't even remember what it means. I'm not going to put that on the test. Comes after. So which ones come after BE? So after BE, you can go EA or ED. Let me just say. That's what it means. Is that good? skip along from there. All right, you okay? Okay, so consider the digraph, vertices, boom. Without drawing the digraph, determine the following. What's the out degree of E? The out degree. In other words, how many arrows pointing out of E? Well, you can just look here, and anything starting with E, it'd just be this one right here, the EB, huh? That one's an arrow from E out to B, huh? That's why there's only one out degree for E. And what's the in degree? Like how many pointing into E? It's just that one right there, huh? Because that goes from A into E. That's why it's just one. Is that good? Just making sure you know what those mean. Those mean arrows. From A to E and from E to B, right? Is that good? Easiest homework you've had all class so far, right? Okay, can I skip over that? Sometimes sociology will use digraphs to connect relationships, how people relate to each other. So basically, this is a respect digraph. So basically, if somebody points to somebody, they respect them. So like E is pointing to A, which means E respects A. B is pointing to A, B respects A. C respects B. D respects C, and D respects E. Okay, so what does that mean then about real life and how they relate? If you had to choose one person to be the leader of the group, who would you pick? You'd pick A. Why? Why would you pick A to be the leader of the group? What's that? Yeah, most people respect, 2 people respect A. That's more than anybody else. A has 2 people pointing towards them. It's the most respected. The largest number of people in the group. Who would be the worst choice? It would be D, because nobody respects D. Nobody's pointing to D. That's smallest number. Okay, C. Assume that you know the respect digraph group individuals, the only information available to you. Which individual would be the most reasonable choice for the leader? The individual corresponding to the vertex having the largest in degree. Yeah, of course. Of course, we went over that, right? Okay, so 8.2, here we go. Project consists of 8 tasks labeled A through H. Processing times are listed below. So this is going to be some information about processing time. So we have task A takes 3 hours. That's what that means. Processing time. So it's like a job. You know, getting the plumbing done takes 3 hours. Getting task B done takes 11 hours. And precedent, that word precedent, what does pre always mean when it's in front of a word? Before. So jobs that must be done before. So you have to do job F before you can do job B. You got to get the plumbing in before you can lay the foundation. Kind of got to get the walls up before you can do the roof. You know, kind of thing. So job F must be done precedent before you can do job B, and job B is an 11-hour job. So this would be the kind of data a manager would have for various jobs that need to be done, jobs that need to be done before that and after that, and how many hours the different jobs take. And then his job or her job would be to manage everything wisely so as not to waste time and waste resources the most efficient way. So there's generally what that chart means. So let's answer the questions. What is the vertex set? Well, that's just A through H, right? Plus a start and an end. A through H, plus there's going to be a starting and ending. We'll get to that probably Monday. I'll tell you about the start and the end. Second question. What is the arc set? That means the arrows. Remember, arcs are arrows. So I don't see any arrows on this diagram. How do I know what the arrows are? Well, arrows go from F to B, for example, because F must be done before B. It's precedent. So basically, it's all these things pointing up. F to C, G to D, C to E. A and H have arrows to F, F to G. That's it. Those are all the arrows. Do you see how the precedent tasks are arrows leading somewhere? So we could list those out. This is F to B, starts at F, goes to B. This is F to C. This is G to D, C to E. This is A to F and A to H. And this is what, F to G. There's the arc set. Now there's actually a little bit more than that. Which tasks have nothing leading to them? Well, A and H. They have nothing down here leading to A and nothing leading to H, which means there's nothing before them. There's nothing pre them. Nothing precedes them. So that means they're done right at the start. So do you understand? It must be start to H and start to A. That's why the real answer has start to A and start to H. Does that make sense? If there's no task before you, you're at the start. If nothing precedes you, if you have no precedent, right? A and H have nothing listed as a precedent task. So there's nothing before them, they are at the start. The start will point to A and the start will point to H. And then here's all the other ones we talked about. AF, right? Here's AF and CE. Oh, and I didn't tell you about the end. There's a bunch of, yeah, how do you know which ones point to the end? They have all these end ones in here. How do you know B points to the end? How do you know B leads to the end?
Because they don't start it.
Because B doesn't lead to anything else, right? So which are not precedents? Which ones are not listed down here? Is A down there? Yes. Is B down there? No. Is C down there? Yes. Is D down there? No. Is E down there? No. Is F? Yes. G? Yes. H? Yes. So these guys are not pointing to anything else, so they must all point to the end. Right? If there's no job after them, if there's no other job they lead to, they must lead to the end. Does that make sense? That's why they have B to the end, D to the end, E to the end, along with all the other connections. We good there? We're going to turn that into a diagram in a little bit here. I don't know if we'll do it today or Monday. But that's the idea of how we'll make it a diagram. Okay, let's see at that time. So let's do that. All right, so how do we take this kind of a chart and actually make an arrow diagram out of it? And that arrow diagram will be really useful for us, make it easier for us to manage the resources. So, all right, how do we do it? Well, first off, remember that let's just start making arrows. F points to B. So I would just simply take a little dot, put an F there, and point to B. Nothing more fancy than that for starters. F points to B. F also points to C. I'll just keep them on the left. F also points to C. So F's also pointing to C. So far, so good? See what I'm doing? I'm just taking the precedent tasks leading to whatever other tasks. And then G points to D. I don't know where that is right now. I can move it later, but I just know there's some arrow G. It points to D. Maybe it should be off to the right or left. Who knows? I'll get that later. But I know for sure there's an arrow from G to D. And there's an arrow from C to E. C's already here. So I'll move that forward to E. You can do it straight. It doesn't matter when up. You can go straight or whatever. There's no magic formula here. A points to F. So A must be back here further, pointing to F. And H points to F, so H must be back here, also pointing to F. Am I going too quick? Is that good? And F points to G. Oh. So F, you could just do like that, but that looks a little crummy. If you want to make it look better, you could move it over here. F points to G, and what did G point to? D. That's probably a little better looking. You don't have to. I'll give you credit for any which way is fine. But it's probably a little easier to look at and use. F points to G, so I moved G forward. But you don't have to. Again, it doesn't matter. And then what else do we got? And that's it, huh? So, well, actually, we've got to put the end, start and the end on now. So now, the start is over here, and the end is over here. And the end is a dot, and the start is a dot. What must the start point to? A and H, the only things that have nothing else pointing to them. And what must point to the end? These guys, and, careful, don't miss the B. The B has nothing pointing to it either. And if you want to move the B more towards the end so it looks better, sure, whatever. You don't have to, it's all fine. But that might look better if you really care about how it looks. That might be better to look at. So there we go. And that shows like a flow. That's easier to follow a flow of how this job needs to be done, huh? You can see we got to start with A and H. They lead to F, break off from there to these jobs, and all these jobs need to be done. Kind of shows things. That's called an arrow. That's the digraph representing the jobs. So you can grab whichever one of those multiple choice options looks like that one. Does that make sense? Questions on that one? We good?